Hi guys, today I'm going to go over completing proofs of theorems involving sides of a parallelogram. Okay, we already did completing proofs of theorems involving angles of a parallelogram. So today is going to be a little bit different than what we did last time, but very similar. Before you get started, I want you to look in the explanation here. It's going to tell you some important things that you should know. A couple of things that you should know is the reflexive property, especially the reflexive property says that if angle A equals angle A, okay? So, or it says that side AB equals side AB. So a segment is equal to itself, okay? You're going to need to know triangle congruence properties because you're going to have to prove two triangles are congruent. So you need to know side, 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 angle, angle, side, or angle, side, angle. Okay. If you don't know those, you can click on that and it's going to pop those up for you to explain them. And then you're also going to need to know the CP-CTC property. This says congruent parts of congruent triangles are congruent. Okay, so it says, so see here, angle A and angle D are equal. Therefore, they are congruent parts of congruent triangles. Okay, so that's what the CP-CTC property says. So let's go ahead and try this and see how it goes. All right, so the first thing I'm going to do is I'm going to redraw this. We're just filling in the blank, so we don't need to know everything. It's not as elaborate as if we were trying to write the proof ourselves. We just need to know the justification behind each part of it. Okay, so R, S, Q, and T. Okay, there's my parallelogram. They tell us that QR is congruent to ST. So the two sides are congruent. They tell us that QT is congruent to RS. So those two sides are congruent. All right. They want us to prove that QRST is a parallelogram. All right. So they send our givens to the proof. Okay. Then they're going to use the reflexive property. We use the reflexive property when we have two triangles that share a side. Okay, so here's one triangle, here's another triangle. They share this side in between. So I know that the side RT is congruent to RT because it is congruent to itself. That is the reflexive property. So now that we have that RT is congruent to RT, we can prove that these two triangles are congruent, okay? Because we have three things. So we're going to say triangle QRT is congruent. So Q is in between the two tick marks and the one tick mark. So we have to start with S, okay? So STR. Okay, so STR. You have to make sure that those vertices are in the right order or this will not work for you. Okay, we know that the two triangles are congruent because we have side, side, side. Okay, so we have the side, side, side congruence property. All right, once we've proven that the two triangles are congruent, we can prove that the corresponding angles are congruent. So angle 1 here is congruent to angle 4, okay? And that's the CP-CTC property. Angle 2 is congruent to angle 3, okay? Now we know that QR is parallel to ST, okay? In order for this to be a parallelogram, that has to be true, because if alternate interior angles, so 1 and 4 are alternate interior angles, if those are equal, then the lines must be parallel. So if alternate interior angles are congruent, then the lines are parallel. Now we say that QT is parallel to RS, because if alternate interior angles are congruent, then the lines are parallel. So if alternate interior angles congruent, then the lines are parallel. Now the definition of a parallelogram is that the opposite sides are parallel and congruent. So these two lines are parallel and those two lines are parallel. Therefore, by the definition, QRST is a parallelogram. All right. I know that this can be a pretty difficult topic, so I'm going to do one more of these. All right. So here is my parallelogram. I'm going to draw this out. I like to draw these out because when I'm proving triangle congruence, sometimes it can be hard to see what we have that is equal in order to prove triangle congruence. So it's easier to draw it out and then mark the figure with what you know, to know which theorem you're going to use for triangle congruence. Okay, so they tell us that W, so this is W, X, Y, and Z. They tell me that WX is congruent to YZ. They tell me that WX is parallel to YZ. So I'm going to mark it as parallel like this. Okay, so they only tell us one part of proving the two triangles are congruent. Okay, we have to figure out the rest of it. So we know that WX is parallel to YZ. That means that when they're cut by a transversal, that the alternate interior angles are congruent. So we can say that angle 1 is congruent to angle 3. Okay, so angle 1 is congruent to angle 3. All right, if lines are parallel, then alternate interior angles are congruent. Now the last part of this, they're using the reflexive property, which we use when the triangles share a side. So here we have, they share this middle side, XZ. So we know that XZ is congruent to XZ. That's the reflexive property. Therefore, we know that triangle WXZ is congruent to YZX. Okay, YZX. It is very important that you put these in the proper order, or this will not work out. So I know they start with W, okay, which is over here, which means I have to start with Y because that's the corresponding part of that triangle. Okay, so we know that that side in common. We need to figure out what theorem we use to prove that these two triangles are congruent. So I have a side, I have an angle, and I have a side. So this is side, angle, side. Okay, so we use the side, angle, side property. All right. Now, they tell us that angle 2 equals angle 4, okay? And that's true because because corresponding parts of corresponding triangles are congruent, the CPCTC property, okay? And then we know that WZ, okay, is parallel to XY, okay? So we know that WZ is parallel to XY. And this is because if alternate interior angles, these are alternate interior angles here, if alternate interior angles are congruent, then the lines are parallel. So if alternate interior angles congruent, then lines parallel. Okay, so now we've shown that XY and WZ are parallel. They told us that WX and ZY were parallel. Therefore, by the definition of a parallelogram, WXYZ is a parallelogram. Okay? All right, I'm going to stop there. If you guys need any help with this, I would be happy to help you.